Look around you today. We live on a quiet, balanced planet, rich with deep oceans, steady seasons, and millions of thriving species. But dial the clock back 4 billion years to the Hadean Eon, and you wouldn't recognize it. Earth was a hostile, toxic sphere of boiling lava, constantly bombarded by giant rocks from space. How do you get from a sterile, molten rock to a world covered in life? The answer lies in a sequence of violent cosmic accidents that literally hammered the planet into shape. The first accident happened 4.6 billion years ago. In the deep, quiet darkness of space, a massive cloud of hydrogen, helium, and dust drifted aimlessly. Astronomers call this the solar nebula. Nearby, a massive dying star exploded. The shock waves from this supernova slammed into our silent nebula, forcing the gas and dust to collapse inward. As the material crashed together, the pressure spiked, driving temperatures at the center up to 15 million degrees Celsius. This triggered nuclear fusion, and our sun ignited. The newborn sun was ravenous. It consumed 99.8% of all the gas and dust in that entire nebula. What remained was a microscopic 0.2% debris ring. Over millions of years, tiny specks of dust in that debris ring began colliding and sticking together. This is a process called accretion. Eventually, these tiny clusters snowballed into massive planetary building blocks. We actually have physical proof of this today in ancient space rocks called meteorites, which contain the original, unmelted dust from before the planets even existed. Without the violent death of a neighboring star and that tiny sliver of leftover dust, our solar system would never have existed. As early rocks smashed into each other, the immense kinetic energy melted the Earth entirely, turning the crust into global seas of glowing lava. Because the planet was liquid, gravity was able to pull the heaviest elements, like iron and nickel, down. They sank to form the core, while lighter elements floated up to form the surface. This sorting is known as differentiation. Down in the outer core, intense heat keeps that liquid iron churning. Because iron conducts electricity, that movement generates massive electrical currents. Those currents project a powerful magnetic field far out into space. Without it, lethal solar winds from the sun would strip away our atmosphere entirely. The hellish melting of early Earth forced the heavy metals to sink, inadvertently building the invisible shield that would later allow life to survive on the surface. We had a rocky planet and a shield, but we lacked water. That arrived from the dark sky. As the planet cooled, icy comets and asteroids crashed into the surface. The heat from the impacts vaporized the ice trapped inside these space rocks, filling the thick atmosphere with steam. Eventually, the planet cooled down enough that the steam condensed, and it began to rain relentlessly for thousands of years. During a period known as the Archean Eon, all that rainwater pooled across the crust, creating the first massive oceans. The very objects we watch the skies for today, asteroids, were the cosmic delivery vehicles that brought Earth its lifeblood. Then came the largest blow of all. About 4.5 billion years ago, a Mars-sized protoplanet named Theia slammed directly into the young Earth. The impact was so severe that Theia's iron core plunged in and fused with Earth's. Millions of tons of vaporized debris were blasted into orbit, eventually clumping together to form our moon. The sheer force of that crash knocked Earth permanently off its vertical axis. We were left leaning at exactly 23.5 degrees. Because of that lean, different parts of the planet receive varying sunlight throughout the year, giving us our changing seasons. At the same time, the gravity of the newly formed moon began pulling on our water, creating oceanic tides that constantly shifted the shoreline, helping early life adapt from the sea to the land. Remove that horrific crash, and Earth is left a stagnant rock, spinning perfectly upright, with no seasons, flat oceans, and likely zero advanced life. Compare Earth to its nearest neighbors. Venus suffered a runaway greenhouse effect that made it a pressure cooker, while Mars lost its magnetic shield in its atmosphere. For life to thrive here, every one of those violent events had to land exactly right. The supernova spark, the iron shield formation, the asteroid water delivery, and the planetary tilt. This billion-year-old stability is what we rely on today. Those same oceans that formed from asteroid ice are currently the planet's primary cooling system, absorbing the majority of the carbon dioxide that would otherwise overheat our atmosphere. Earth isn't a guaranteed home. It is a highly improbable alignment of chaos that happened to work. Understanding how much had to go right just to get us here makes our responsibility to maintain it feel much more urgent.